We'll be starting at 7:05, so just MIT time. We'll be starting 5 minutes past the hour. All right, welcome to lecture 2. So today is our first formal lecture after kicking off yesterday. So in today's lecture, we'll be covering mainly 3 key things. We'll be covering how to get set up. So there's a little bit of setup involved in making sure that everything is ready to go on your machine to be able to run a Battlecode game and be able to develop things properly locally. We'll be going through an introduction on how Java works, and we'll also be looking at how to get started on your Battlecode bot. So my name is Jerry. I'm here. I'm one of your lecturers here today. With me, we have Andy, who's here as well. So the 2 of us will be walking you through a couple things together. Great. So I guess we'll get started. If you have any questions, feel free to either ask away in the Twitch chat. You can also, so either in the Twitch chat, if you have other questions, you can also ask them in the Discord lectures channel. We'll be watching both of those and following up on anything you ask there. Cool. So I guess let's get started. So really to get started, one of the first things you want to be looking at is the scaffold. So the Battlecode 2022 scaffold is where all of your initial, it's really a starter pack for being able to do anything, for really getting started with Battlecode 2022. So the scaffold looks like this. I'm going to try to share my screen and see, and hopefully this works nicely. So this is the Battlecode 2022 scaffold. The scaffold is your starter pack, and it's what you'll be using to really get started with your Battlecode bot. So what you want to do is, the first thing is on your GitHub account. So if you don't have a GitHub account yet, we would strongly recommend that you create one, especially since we'll be having an introduction on how to use Git lecture in a couple of days' time. But on your GitHub account, what you'll want to do is you want to go into the top right corner there and create a new repository. So the new repository will be your home for your code. So I've already got that window open here. And so to create a new repo, what you want to do is you want to give your repo a name. And so what we will be developing together, our lecture player, and our lecture player is going to be the bot that we'll be working on improving over the next week or so. So the lecture player, we're going to start out with example funcs player, and then every lecture we're going to work on improving it until we have a pretty good bot and lecture player together. So for you, you're going to create a bot. You're going to create a new repository with a nice name for yourself. The key thing is we're going to actually make this template the Battlecode 2022 scaffold. So we're going to create a new repo with a Battlecode 22 scaffold. For you, you may actually also want to click on the use this template button, which will also let you use this 2022 template to create a new repo for yourself. So I'm going to use this template to create a new repo containing your code. We're going to make this a public repo so that we can actually see everyone, you can all follow along with the code that we create. So let's create this repository and see how we go. All right, so lecture player is being created. And after lecture player is created, what we're going to do is we're going to go into our local code and we're going to clone it. So there's a couple ways you can do this. The key thing is that you can actually use the command here under this code button to download your repository. So I'm going to use this command here. So I'm going to copy that and I'm going to paste that here. Should have pressed git clone that. And then that's going to go download our code. And we have now got a folder which contains all the code that we have just cloned. So this is our own copy of the scaffold. So we now have our own repository, our own home for our code, which is going to be our scaffold. So now that you have this, the key files you want to be looking at are this, is the source example funcs player, robotplayer.java. This file contains all the starter code that we have provided that lets you get started with the game. But I would imagine that a lot of us don't want to be developing straight out of a terminal window like this. So what we're going to look at is we're actually going to do two setups together, depending on your preferred IDE. I'm going to show you how to get set up on Eclipse, and then Andy's going to show everyone how to get set up on Intellij, so that these are some of two of the most common editors that we see everyone using. So we're going to show everyone how to get set up on these, so that you can get your bot running in your favorite IDE. So this is my Eclipse window here. It's a fresh install of Eclipse, almost a fresh install of Eclipse. So what I'm going to do is I'm going to go through how to import this Battlecode 2022 scaffold into Eclipse. The first thing you want to do is actually, on my Mac, I go into Eclipse/preferences, but you want to be looking for your settings option on Eclipse. And inside your preferences, you want to go into your Gradle settings. So Gradle is the build system that we're using in Battlecode 2022. The reason we come into the Gradle settings is because we want to make sure that your Java home is pointing towards the correct Java version. So the Java home is the Java home is like the home of where all of your Java is going to be coming out of. And specifically in this year of Battlecode, we're officially supporting Java 8. So you want to make sure that you see that 8 in here. So if you have a different installation of Java, you want to go and click that browse button and make sure is pointing towards the Java 8, the home of Java 8. So specifically, you can see here that I've got another installation, which is Java 17. And so this is not the version of Java that we want to be using. So we're selecting the Java 8 home in here. And so we're going to select that and we're going to apply and close. Once we've got that done, we've now got Eclipse pointing to the correct version of Java. So now we can go ahead and import our new project. So we're going to import a project, which is the code that we just created on GitHub. So we just took the scaffold and created a new repo out of it. So we're going to take an existing Gradle project. So the scaffold is a prepared Gradle project that's ready to go. So we're going to go in here and you're going to select an existing Gradle project. You're going to go through to the next step. This is a nice welcome introductory screen, which we're going to skip through. And then finally, you're going to go into here, you're going to browse and you're going to find your lecture player. The lecture player is the file that you want to be using, is the folder that you're going to be wanting to be selecting. So you're going to select this lecture player here and open it. And so you can see lecture/lecture player, or wherever you cloned it, wherever you saved your code locally, you're going to pick it into lecture player. And you're going to click finish here. So just a moment while this sets everything up. And it's now set up. Cool. So we've now got lecture player inside our workspace. So if we take a little look around, we can see example funcs player in here. You can double click on robotplayer.java and you can see that this is all the sample code that we have. So this is all the code that exists. And the key thing that I want to point you towards is if you go down to the bottom down here, there is a window that says Gradle Tasks. And if you expand lecture player and Battlecode, so lecture player again being the name of your repo, but if you expand the name of your repo and you expand Battlecode, there's a couple of different tasks that are available. Now, these tasks are the ones that let you be able to run games and experiment with the bot that you have. I recommend as the first thing you do before doing anything is you update just in case there's any new updates coming from us. So every time we say that if we fix any bugs or if we make any adjustments to the Battlecode game, you can pull those in with the update command here. So if you just double click on update, that's going to detect any new versions that have been released. So that's the update done there. And then the key thing then is we can now click on the two key things you'll probably want to be using are the build command. So if you double click on build, this compiles all of our code. So you can see that it's running. And then once this finishes, this says that our code works. So what it means to compile code, if you're coming from a Python background, is you can think of it as converting it to like an executable that's running, ready to run. Not exactly the case with what's happening perfectly under the hood with Java, but that's sort of like the general idea. You can also think of it as a nice syntax check. So if you're writing a Python program and it's going to throw a syntax error, compiling your code actually catches that first. So when you compile your code, if you have anything that's not good syntax, compiling it will catch it. So for example, if I throw in some extra text there, and then I click on build, I should save robot.java first, and then I click on build, that build step fails. And if you then go into your console, you can see the reason for that failure. So if we scroll back up, it says there's an error here on the ASDF, which it doesn't recognize. So that's one thing. The other thing is, let's save that change there. So build lets you compile your code, check that the syntax and everything is perfect. The other thing you have is run. Now run is the command that runs your code. So it actually runs a match. So if we double click on run, it's going to compile it again, and then it's actually going to start running a match. So if you go back into your console, you can see that this is the output that is coming out of your robot player. So a lot of output coming out. This is essentially everything that the robot player is saying. We'll come back later and discuss how it's saying these things. But this is sort of, showing you that like, yes, the game is running, it is working. That's the most of the local setup. The other thing that you actually have is a thing, the other thing that you actually have is the client. We'll look at the client in a moment. This game is taking a bit of time to run. We might actually wait it out so that we can actually see how to view the result of a game together. Okay, actually, this might take longer than expected. So we'll go through how to view a game. Let's come back to me. Let's start the IntelliJ setup, and then hopefully by the time IntelliJ is done, we'll also have a setup here that lets you view the game. So I'm going to switch over to Andy now, who's going to do the IntelliJ setup. So Andy, you want to take over to share screen?
Yep. So sharing screen. Hopefully everybody can see what's going on here. And here we're just going to be covering the IntelliJ setup. So this is just an installation of IntelliJ. I've done a few things for the upcoming lecture, but these files aren't really important. And we're going to start off assuming that you have the JDK installed for Java 8, and we're also going to assume that you have IntelliJ installed. If you want instructions on how you can install either of those are on the Battlecode website under Getting Started, and you can just go and navigate through the instructions for those. So as Jerry stated, the Eclipse and the IntelliJ setup both sort of start by cloning the repo or downloading the zip file. Either will work. And if we look at the current file system I have, you can see that right now we actually have a copy of the repo right here. And this is what we're going to be using to set up the IntelliJ. Now to actually set up the IntelliJ, we can first navigate to the file up here. When you open a fresh copy of IntelliJ, it's actually going to be showing a different screen, but you can just navigate up here to file, and you can just open up the corresponding file that you want. So here I'm just going to navigate to my cloned version of the GitHub repo, and we're going to open up the build.gradle file right here. And it's going to throw us some messages here. We just want to open it as a project, and we want to trust the project, and we can either open it in a new window or this window, it doesn't really matter. So now here we have the project set up, and we need to do a few things before we can actually start running the project. First, we're going to go to File up here once again, and we're going to navigate down to Project Structure. And here you can see the SDK is Java is 1.8. And if you sort of click on this, you can look through the different versions of the SDKs that you have. I have a version of Java 16 installed. There's also Java 8 right here. And we just want to make sure that we have Java 8 so that we can run all the code properly. And in the case that you can't find it, you can just click on Add SDK and sort of navigate down to where the files are. So we're just going to click OK here. I didn't have to change anything since I was already on Java 1.8, but you just want to confirm that you're on the right version. Once we're here, we're going to go to the right side of IntelliJ. You can see a little elephant symbol with Gradle. We're going to click on this to pull out this tab right here. And once we're here, we can sort of pull down the tasks folder here, pull down Battlecode, and we can find all of the different commands that we can find that we can run corresponding to the ones that Jerry showed on Eclipse. So you can see we have build right here. If we want to build the project, we have run for running a match, and we have update to check for any new updates. So with this fresh version of the project, we're first going to want to check for any updates. You can see it run down here, and it's finished checking for updates. And secondly, we're just going to run build. And this is going to take a little bit, but it's going to execute the build, make sure that your code runs smoothly. And if you actually want to navigate to any of the files, we can sort of just go into the source, and we can see example funcs players files right here. The screens are a little large. We can sort of just pan them to the side, so it's a bit easier to see our code. You can see here that the execution has actually finished, so the build's finished. And you can sort of tell that it's finished because a client folder should appear right up here with an application. Now, we can also click the run here as Jerry did in the Eclipse version. It should work the exact same way. And you can see it's just running a match down here, and this is going to take a while. And I think Jerry's running this right now. So we can actually just terminate this early. And moving on, there's a way to open up the client application here itself. If we actually navigate to the folder itself and find the application under file, you can see it's sort of an applet that you can open. You actually have to be a little careful about opening this applet because it only opens. So if you have a different version of Java installed besides Java 8, it's going to cause errors because it's going to default to that version of Java, and that's going to not work. So instead, we can actually open it from terminal after setting the right terminal version. The way I can do this is right now, if I just query the Java version here, you can see I have Java 1.8 set as the version. If you want to learn how to change the version, you can sort of just Google this online. It's pretty, you can sort of just copy and paste the commands online. And I think it's also covered on the on other resources on the website. So if I navigate to the applet here, I pull up the repo here and I navigate to the client folder. This is the applet. I can just, since I'm on Mac, there's a command called open. I can just open this file up and we can see the client here where we can play replay files, we can run matches, edit maps, etc. So this is sort of just all you need to set up the IntelliJ. If you have any other questions, you can post that in the Twitch chat or the Discord. And hopefully the match has finished running on Jerry's end. So
yes, the match is finished running here. I am going to, I guess I can quickly steal the share screen, although sort of, I guess we already have a decent idea of how the client works, but just for the sake of completeness, what we're going to do is this is sort of like the set of commands we're going to use. So if your Java is the wrong version, so I'll actually let's actually do that together. So let's not update my shell. But if we check out my Java version, it's by default pointing to my Java 17, which is not a very good thing to have. So what I'm going to do is I'm actually just going to be a bit lazy here and I'm going to copy this command. This command here sets my Java home to my Java 8 home. So this is the same home that we had before. So we're going to run that and you can actually check that my Java version is now Java 8. And then the second thing we're going to do is that same open command before. So we're in lecture player and you can see that we have now got the client folder. So the client folder appears when you successfully run a match. And then if we open that, we will have the client. So inside the client, we're able to run games here. So these are the settings that let you run games. So you can actually just select your teams. You can select the maps you want to run on, and then you can just run the game directly. Since we've already run a game, so I'm just going to show you how to upload a match. So we're going to go to desktop. We're going to go to the lecture. We're going to go there. So after we ran a game, we have the matches folder show up. And inside the matches folder, there is a BC22 replay file. So if we open that, we can actually see this game in action. So we've now got the robots moving around on the screen. And there's 2,000 rounds of robots sort of just moving around randomly, which is what example Flux Player does. But this is sort of how you can get yourself set up with the client. So that's my little interruption with the client. I'm going to turn it back to Andy, who's going to start off our section on Java. And if you have any questions about the setup, please do throw them in the chat.
All right, so now we're just going to go over some basic Java syntax. So we're going to be covering a few topics today. First, I'll be presenting the topics related to type safety in Java. And we're going to be covering four different issues that you can run into, and just some different aspects of Java that you should sort of approach that might be different than previous languages like Python you might have worked with. Now, there's a few differences between languages like Python and Java. Java is a lot more rigid than Python. You need to declare types. You need to constrain a lot of your variables and constrain a lot of the things you can do. So your movement is a lot more limited compared to Python. Now, this makes it so that you can't do a lot of things, but on the other hand, this is also really good because it helps you prevent a lot of unforeseen bugs where maybe you accidentally set something to a null or a none in Python, or if you accidentally set it to the wrong type, this issue cannot occur in Java because you need to specify things like this. So we're going to start off with a pretty simple program. here we have the class and a public static void main method. So basically, everything that is in this method is going to get run from top to down. And we can see we've basically created a variable. We've specified its type to be an integer, which means that it can neither exceed a certain limit and it has to remain integers. So we can't get numbers like 0.3, we can't get numbers like 0.5, and the limit of the number is also constrained. So we can't put in a really big number, like something like, I don't know, 10 to the 30, and we can't put a really small number like negative 10 to the 30. More specifically, integers constrained between the range of negative 2 to the 31 to positive 2 to the 31 minus 1. So with that knowledge in mind, we can see we sort of initialize an integer here and we name it lead and we set its initial value to 100,000. So let's say our robot wants to sort of calculate a heuristic or an algorithm. We determine whether or not it's worth to mine this piece of lead. So we want to square our value of lead somewhere in this algorithm. So we set lead to the square of lead. So this should be 100,000 times 100,000. Which is a pretty big number. And the question here is our print going to work? So actually, just if you're in chat, Twitch chat or Discord, you can sort of just post whether or not you think this is going to work and sort of what number do you think it's going to spit out? And maybe I'll just wait like a few seconds to see if anybody has any ideas here. Okay, I can't really see the chat now, but if you said that it wasn't going to work, you're correct, congratulations. And if you said it was going to work, you missed the issue in that integers actually have limits. So if you remember, integers are constrained to the range negative 2 to the 31 to positive 2 to the 31 minus 1. And 100,000 squared is actually much larger than 2 to the 31. So if we try running this program, here I'm in IntelliJ, so we can run by just saying Java, then calling this file name. So type safety1.java. We can see it's actually going to give us a number that is not expected. 100,000 times 100,000 is not supposed to be this number. And the reason for this is because it overflows the limit of the integer. And the way we can fix this is actually using a different type called a long. So a long is instead of an integer is constrained with twice the bounds. So essentially it can go to negative 2 to the 64, negative 2 to the 63 to positive 2 to the 63 minus 1, whereas the integer can't actually have that many bits. So if we set this to a long, we actually have a much greater range of motion here. And if we run this again, we get the correct solution. Now, something to be wary of here is that when we had this as an integer, this actually didn't throw an error, even though there is an overflow. So if we were unsuspecting and this was in a larger program where we might not be so aware where the error is, we're not going to get a compile error or a compile warning when we have an overflow like this. Instead, we're just going to sort of get blindsided by a number that we're not expecting. So it's always important to be aware of the limits of your variables, as well as the types of the variables in Java before we start working with them. So when we initialize this value, you need to think, is it going to exceed a very large value like 2 to the 31? If so, we need to remember that it needs to be a long. And yeah, if anybody has any questions about this, they can post it in chat and hopefully Jerry and I can answer them. Now we're going to move on to a slightly more complicated example. Here, instead of the overflow of the integer, we're going to look at a different thing that can occur in Java, which is casting. So recall that I said that an integer can only take on integer values. So if you want an integer to be 0.3 or 0.5, it's actually going to round that down towards 0 and set 0.3 to something like 0, something like 1.3 to 1. And if we're not careful with working with decimals and integers, we can get a lot of issues here. So here we have something called a double. A double is essentially just a number that can also be a decimal. So here, since we're working with a percentage like 0.1, we need to work with a double instead. And similarly, we also have this keyword here, final. People who might have worked with Python might not be so familiar what final means. Final is essentially a way of saying that once we create this variable, we aren't going to change it at all. So if later on in the code, we try something like abyss percentage is equal to 0.3, this is actually going to throw an error because abyss percentage is supposed to be a constant of final and it shouldn't be changing. Now, with the knowledge that integers can only take in integer values in mind, what do you guys think will actually occur here if we try to run this calculation where we multiply led by abyss percentage and set it to an integer value? I guess I'll give like maybe 10 seconds for you guys to think, and then I'll just quickly go over what will happen.
Generic username thinks we're going to have a compile error. But
yes, we're actually going to get a compile error here. And the reason is because when we multiply an integer and a double, when we multiply 25 and 0.1, Java's going to look at these and say, well, we're assuming that this person is going to want the result to also be a decimal since they're including like a decimal in the calculation. So the result will be 2.5, which is a double. But unfortunately, abyss lost, which is our variable, is an integer. So it's going to try to set an integer to a double, and it gets really confused because it doesn't know which one you want. So if we actually try running this code, type safety 2, we see there's a compile error because there's incompatible conversion from double to int. Now, to fix this, there's a few ways. So first, we have to think, what do we want? Well, do we want abyss lost to be an integer or a double? So let's assume that we want abyss lost to be an integer, and we want the amount that's lost to be 2 instead of 2.5. What we can do here is called a cast. So there's also cast in every language. In Python, you do it in a different way than Java. In Java, you sort of need to include the type that you wanted the value to turn into inside these parentheses, and you want the value to be casted inside another set of parentheses. So here, this value internally is going to calculate to 2.5. We're going to want to cast it to an integer so that the variable can process it. And then now, if we run this code, it should give us a nice value of 23 remaining lead. Now, note that doubles when casted to integers, or floats when casted to integers, any decimal when it's assigned to an integer is going to round it down towards 0. So this means if we have a value like 2.8, that's going to round down to 2. If we have a value like 100.3, that's going to round down to 100. And more in a bit of a trickier fashion, if we have a number like negative 10.8, that's going to round to negative 10 instead of negative 11. Just another thing to keep in mind. Now, alternatively, in this case, let's suppose we actually want to work in doubles. We want abyss loss to be 2.5, and we want the final amount of lead to be something like 22.5. Then we need to remember that we need to be a lot more careful with the types of our values. So lead would have to be a double, and abyss loss would similarly have to be a double for this to work. And if we run this code, we can see that the amount of lead remaining is 22.5, and we're not losing this information during the calculation. Now, if anybody has any questions about this, they can ask it in chat, and hopefully Jerry and I can answer them. Otherwise, we'll be moving on to the third file, type safety 3. Now, this file is a bit more complicated. It's a bit more intimidating, but it's essentially a set of functions, and here's our main. So these 3 lines of code will be run in the main. They'll call their respective functions down here, and it should execute the lines of code inside the functions. Now, if you're coming from a Python background, once again, there's a few things that might look unfamiliar to you. So the first thing is that every single function in Java needs to have a type associated with it. So for example, let's say we want a function that's going to return the sum of 2 numbers. If the 2 numbers are integers, the return type should be an integer. So we need to specify that in the function title. So here we have a function called calculate sum of numbers, and it essentially takes in the list of numbers up here that we've declared, and it's going to calculate the sum. And since the sum's an integer, we need to specify that the return type is going to be an integer as well. Now, this naturally leads into the question, what if we have a function that doesn't return any value? What are we going to put as its return type? So Java actually has a very handy thing here called void. And in the case that the function doesn't return anything, if it's a function like move right or move up, something that doesn't necessarily need to return a value, we can actually give it the type void. And this means that the function isn't going to return anything. And it's a sort of a special type that can only be assigned to functions. So integers, doubles, floats, strings can all be assigned to variables. Void cannot be assigned to a variable. It's constrained to functions. Now, the other thing keen viewers might notice is that this variable numbers is actually not inside of the main class and not inside a function class. So in Java, you can sort of have these variables linger outside of any functions, linger outside the main. And these are very conveniently shared between all of the functions, such that we don't really need to pass in numbers in each of these functions. Instead, it's sort of preserved between every single one of these as a global type. Now, something to be careful is that when we do this, we need to remember to use the static keyword in front of it. And this essentially allows it to be shared between all of these functions. Now, one more thing here is that we're using something called an array. So Python has lists, which are essentially pretty similar to arrays, but there's a few key differences. First, in Java, when we create arrays, we need to specify the type of the array and the size of the array. So if you think about Python lists, you can sort of just append objects to the end. You can add objects all throughout, and the objects don't necessarily have to be the same type. You can have a list of the word hi, followed by the number 3, followed by -2.5. But in Java, we actually need to specify what type every single element in the list will be. So here we're creating a list of integers. We haven't specified the type yet, since we actually haven't initialized the list. But every single thing that's entered into this list will have to be an integer. So now that these things are sort of gotten out of the way, we can sort of look at what the code does here. So first things first, the main function is going to call this function fill array with numbers, which can be found here. If we look at this, it's going to go through the numbers 1 through 10, 0 through 9, using a for loop. This is equivalent to just saying for I in range 10, if you're familiar with Python. But essentially, it's going to iterate the numbers from 0 through 9 and set the indices of numbers to 0, 1, 2, 3, etc., all the way to 9. Next thing, we're going to calculate the sum of the numbers in the list, in the array. This is going to use something called an iterator. And it's essentially the same thing as saying for value in numbers, if you're familiar with Python, where we're essentially just going to go through every single value that's in the numbers array, and then just add them to our variable total, and then finally just return total. And here we have just another function that I'll be briefly covering later, but it's essentially a way of creating, of initializing this variable in line. So looking at these two functions and the main function, there's actually a problem in the code. So if anybody has any ideas as to what this problem is, they can quickly type it in the chat. I'll give you a hint. It has to do with sort of a mix of how we're creating the numbers array and how we're sort of using it in this function here, fill array with numbers. I'll wait maybe 10, 15 seconds to see if anybody has any ideas, and I'll just go over what's wrong.
So we have a suggestion that we haven't declared a size for numbers. We don't know how big numbers is.
Exactly. So as I mentioned before, numbers has not been initialized. So right now, numbers is just a variable, but we don't actually know how large it is. And we actually don't know like what it is at all. So in order for this to work, we need to do something like new int or 10. And this sort of lets us know that this is an integer array of size 10. And now if we run
happens if you don't initialize it, do you want to show us what happens if you run it without that?
Yes. So let's assume that we did not catch this bug and we actually ran it. So here we see that it's going to throw an error. It's a null pointer exception because numbers is currently assigned to something called a null, where it's essentially non-existent at the moment. And we try to do something called, we try to index into numbers, indexing arrays works the same way as indexing lists in Python, actually. But numbers doesn't exist. So when we tried to do this, Java throws a fit about it, and we actually can't proceed with the program. Now, if we actually do assign numbers to a value in the memory, and we run it like this, we get a value 45, which is the sum of the numbers from 0 through 9, which is correct. Alternatively, let's say we didn't necessarily know, let's say we knew what we wanted the values of numbers to be, and we didn't really need to use a fill array with numbers function like this. We sort of wanted it to be like the list 0, 1, 2, 3, or in this case, the list 0 through 9. So let's say we already knew what we wanted it to be in the code. We didn't need to do any calculations. You can see here, get list of numbers is returning an array of just the numbers from 0 through 9. Here, the initialization works by saying the type of the array, demonstrating that's the array with these 2 square brackets, and curly braces, we can sort of just list all the values we wanted there. So instead, if we call get list of numbers, and instead of filling it up, we just say, we can just set numbers equal to this at the start, and then just comment out this line. I believe this should also work. Yes, and you can see it also gets the value 45. And instead of sort of running this line here and specifying a size, we can just directly input what the array is. If anybody has questions about this, once again, they can just post in chat and Jerry and I will answer the questions. Finally, we're just going to look at one final program about type safety. And this is sort of using a new data structure called an array list. So recall that arrays are really constrained compared to what they exist in Python for 2 reasons. First, you have to specify the type of every element in the array. And second, once you give it a size, you can't really change the size. Now, Java actually has a data structure that sort of circumvents one of these issues. Array lists are essentially lists that can, arrays that can change size. So you can append to the end of them, you can delete from the end of them, and you can also resize them as necessary. So there's a few things to know about this program first. First, here we have array list as the type that we're using instead of using the 2 square brackets to indicate an array. The second thing is that we actually have to import this. So Java has a bunch of libraries and array list is in one of them. So if we don't have this import, the code is not going to recognize what an array list is. We have to import this library to sort of have the code recognize that this exists. If you want to look at a lot more cool imports, you can sort of just look at Java util. This has a lot of really cool data structures and other functions that are really useful. Just for an example, we have hash maps, which are essentially equivalent to dictionaries in Python. And we have hash sets, which are equivalent to sets in Java. And there's a lot more too, if you want to look those up on your own time and sort of dig around on what there is in Java. So here, similar to type safety 3, we declare an array list outside of the main function. This lets us use it between any functions that we might write, and it essentially makes it a global variable. Now, if you might notice that here, we're trying to create an integer array list where all the values in the array list are integers, but instead of using something like int, we're actually saying the entire word integer capitalized here. Now, the reason for why we have to do this is actually a little complex, and it has to do with how Java works around how different types are handled. But just keep in mind that if you're working with integers, doubles, floats, longs, you have to use the capitalized version of the word written out. And it's actually the same thing with Booleans. If you want to look more on the reason, you can sort of search this up online. And if you want to see if the data structure you're using requires sort of this notation, you can also check that up online. So with that out of the way, let's look at sort of what happens inside the main body of this function. So first, we're trying to add the value 3.7 to the end of the array list. Add is essentially the same thing as append, if you're familiar with how that works in many other languages, including Python. Then we're going to try to add the numbers 2, 3, 4. We're going to try to do something a bit spicy and add a null to the end of the array list. And then we're just going to try to iterate through the array list, sum up all the values, and print that out. Now, before we get to sort of what's happening down here with iterating over the values and summing them up, as well as adding the null, I want to focus on this first line up here, where we're adding 3.7 to the array list. Now, this is not going to work. And if anybody has any ideas as to why this isn't going to work, I'll just give a few seconds for them to sort of post in either the chat or the Discord chat as to why they think this isn't going to work, or what error do they think that it will throw. I'll wait maybe 10 seconds here.
Right. A lot of people are saying that it's a double, and doubles aren't ints.
Yep, exactly. So if we remember from our second file, we need to be really careful what types of our values we're putting in. So 3.7 is a decimal, so it must be a double. And if we're trying to put a double in an integer array list, this is going to throw a bug. This is going to throw an error message. So if we try running this, we get the error message that a double cannot be converted to integer. So in order for this to work, we have two options. We can either cast this as an int. I accidentally deleted the 3 here. In this case, we're actually just adding 3 into our array list. And our other choice is to change the type of the array list to something like a double here. So in this case, we're just going to comment out this line of code since we have some further addition statements here. So now that we know that the double issue is not a concern, let's look at these next 3 lines of code. We're just appending the values 2, 3, 4 to the end of this array list. Now, once again, I'll give maybe 10, 15 seconds for people to answer whether or not they think this is going to work. And if it's not going to work, what they think the problem with the code is. And this is a bit more tricky. Okay, so if you answered that this is not going to work, you're correct. And the reason this isn't going to work is, once again, it has to do with the initialization. So remember that when we don't initialize things, they're actually sort of just not really assigned to anything. And we saw this example back in our array list array example, where when we didn't have this initialization here, numbers was sort of just assigned to nothingness. And when we tried to use numbers, it would just break. We actually need to do the same thing here with array lists. So right now, numbers is actually not really assigned to anything. In order to assign it to something, we need to say something like new array list like this. And this just creates an array list of size 0. So now numbers is an empty array list we can add to the end of it. Before, it wasn't an empty array list, it is actually just a null. And trying to add things to that doesn't work in Java. So if we try running this now, we can see that the error that occurs is actually on line 23 down here. So it's actually gotten safely past all of these lines and it hasn't run into an error. So if we look at what's in numbers, for example, if we just say quickly .out.println numbers, I think this should work. We can see that it's an array list of 2, 3, 4, and null. Now, with this in mind, we can sort of see that line 23 here broke, where we are trying to access element I of numbers and add it to total. Now, the reason for this is, so actually, before I cover this, let's quickly go over what each of these functions do. So to access the size of the array list, since this is constantly changing, we can call numbers.size, and that's going to give us the size of the array at any given moment. So after adding 2, 3, 4, and null, there should be 4 elements inside of numbers. So calling numbers.size will tell us 4. And this is super useful if you want to do any kind of math over the array, iterate over the array, or sort of use the indices of the array in any fashion. And finally, we have this function here, numbers.getI. So if you recall with Python lists or Java arrays, we can sort of use the square brackets to access the ith element. But since array lists are a bit special, if we want to access the ith element of numbers, we need to use the .get function. So let's say we want to read the ith element of numbers, we can use numbers.getI. Now in the case that we want to change the values of the ith element of numbers, we can instead use numbers.setI in order to change. We need to say something like numbers.setI to like 10 maybe, and this is going to change the ith element to 10. So that's just quickly covering what's really going on in these 3 lines. And you guys know that this code doesn't work, but if anybody has any ideas as to why it doesn't work, I know it does give a little bit of context down here. They can quickly post it in the chat, and I'll wait maybe a few seconds before covering why it doesn't work.
You are faced with, oh, we have plus is not a valid operation for null. So it works until we hit be null, and then we're confused.
Yes, exactly. So null is sort of equivalent to none in Python. It's a bit more picky about when you can use it and when you can set values to it. So for example, you can't set standard ints to it, but you can set like integers and strings to it. But it's essentially equivalent to none. And recall that currently numbers has 2, 3, 4, and null. And we're trying to add the values up together. So what's 2 plus 3 plus 4? Well, it's 6. No, I'm wrong. It's 9.
It's 9, Andy, come on.
It is 9. I swear I passed my 1802 exam anyways. Okay, so it's 9, but then what's 9 plus null? Well, Java doesn't really know what 9 plus null is. Is it null? Is it 9? Who knows, right? So you can't actually add null and any other kind of thing together. It just sort of breaks on the spot. So here we need to remove this line, or we need to remove it from the addition. And if we run this now, it's going to give us the nice value of not 6, but 9. So now that we've covered the 4 type safety questions, I'll hand it over to Jerry, who's going to cover a few more topics. And I'll monitor the chat for any questions that you guys may have.
Cool, thanks. I'm going to jump in the share screen here. I'm actually not as cool as Andy, and I don't actually know how to use IDEs properly. Despite having just set one up, I live in a terminal. So you're going to get to spend the next little while staring at my amazing terminal screen, looking at some more snippets of code. So continuing our series on how to work with Java, we've got another piece of code here so we're going to move away a little bit now from types. So we're going to move away through to like a couple other things and gotchas to watch out for. So a couple of things can behave strangely. So first up, we have something that looks like a pretty nice and innocuous piece of code. What we have is simply we're creating 2 map locations. So like remember in Battlecode, your map location represents a location of the map. So we have one location, probably shouldn't have called it X, but I guess it's X and Y now. We have one location, which we're calling this location X, and it's at square 2, 3 on the map. We have another location, it's square 2, 3 on the map. And then we're just asking the question, is X and Y the same? So I'm gonna give everyone a couple of moments to think what this piece of code will output and why. So I guess, Andy, do you want to read to me what people think, if there's any ideas on whether people think X and Y are the same or if they're going to be different? I'm going to compile this code while we wait. I guarantee this code compiles. All right.
So one person here has said that different memory locations are different.
Okay, yes, this is a very good point. So different memory locations are different. That is absolutely correct. And I'm going to rephrase that in a way so that we can sort of pick apart at what's actually happening here. So I'm going to run this code, and yes, it outputs that they're not the same. Now, the specific reason for this is the equals comparison in Java is a lot like the is comparison in Python. So you might remember in Python that x is y and x equals y mean something really different. Like x equals y compares whether or not two things represent the same stuff. But the x is y checks whether they're actually the identical thing. And so this is something to be really careful about when writing your bot, because I know that when I wrote my bots, I often did x equals y, things like this, and got myself in really confusing bugs. So the fix to this is, well, like the specific problem here is that even though x and y are representing the same application, they both represent 2, 3. When you write new, you're actually creating a new object, a new application object. And so they actually, even though they represent the same thing, they are two different things themselves, which is why, so just like in Python, if you did an x is y, you're going to get two different things. Like we can actually do that together in Python. If we have some class application, which I'll just pass on. If I have x is a application and y is a application, then x is y would be false, because x and y are fundamentally different things. So the way to fix this here in Java is we want to remove this line of code, and we want to instead say if x dot equals y, and the x dot equals y is now what is actually the Python equivalent of that is x equals y, which is a bit confusing because the equals does different things in the two languages. But here, when we do if x dot equals y, then if I recompile this and then I run it, then this will say that they are the same. So just a quick gotcha there to watch out for, because this is actually a very common source of bugs. It's definitely happened to me a lot. Yes, this is the thing about, this is sort of like a general idea of Python classes. Essentially, each class, so everything is a class here. Python definitely uses a lot of objects. But remember that every time you use new, you might end up with a different object. So be careful, and if you know that you could potentially run into an issue like this, dot equals could be a safer choice than x equals y. If there's any questions about that, please drop it in the chat. Otherwise, I will move on to the next and last snippet of Java. Okay, so this is a bit of a longer snippet of code, so we'll pick this apart together. So you can ignore the scanner business. The scanner is like our Python input. Quite conveniently, Java takes a little bit more work to set up an input, but essentially what this code does, we'll actually we'll run it in a bit. Let's just read this code together first. What this code is saying is what we're going to do is we're going to repeatedly. So you'll notice that a lot of your loop control, or like your control flow, is really similar between Java and Python. So like your while, you have your while true, which is exactly what you'd expect in Python is your while true as well. You have ifs. Java doesn't have elif. You have to actually write out the else and then the if. So like the elif that you do in Python doesn't exist here. But we do have else if. So you have what we're essentially saying is, well, we're actually just checking, is this number a multiple of 3 or 5 or both? So we're saying we're asking the user for their favorite number. This scanner here is essentially saying we're going to input a number. So this is like your Python input. Let's read a number from the input. So we're asking the scanner to give us an int, which is a number. And then we're just going to check, is it both a multiple of 3 and 5, or is it only a multiple of 3 or only a multiple of 5? We're actually going to say that 26 and 32 are mysteries. So if it's not 26 or 32, then our sincere apologies, but you have a very terrible favorite number. But otherwise, you really do have a mysterious favorite number. And we're just going to do this on loops so that you can pass this program around to your friends and ask them to input their favorite numbers as well. So the first question is, do we think this code compiles? So remember, compiling is checking for syntax errors. That's a really big part of compiling. So do we think that this code will compile? Are there any syntax errors in this code? What do we think? And if you think there are syntax errors, where do you think they are?
We have some people saying that the loop will not end.
The loop will not end. That is a very good point. The loop will not end. Although, even though the loop won't end, you can still write programs like this. They're still syntactically okay. The syntax is perfect. They just end up doing something forever. It's a very good point, though, that this loop will not end. But the loop not ending is not a syntax problem. There's actually a bigger syntax problem with this code. This code actually does not contain valid syntax. It actually, and if we compile it, it actually outputs a lot of stuff about why Java doesn't like our code. And at a first glance, this is actually not very descriptive. Like, it's just saying that Java is saying that over here, right here, it really wants to see a parenthesis. Like, it doesn't like the word and for some reason. Like, it just wants to see a parenthesis. And it says that here as well, right before the or, it wants to see a parenthesis. It wants to see this if closed. It turns out that in Java, the way you actually combine conditions is actually not using the English words and or. Java actually likes to use symbols here instead. So and is actually not a keyword in Java. So you can't actually use and like this. Instead, the way you take the logical and of two booleans is you use the double ampersand symbol. So you have to put two ampersands there, and the double ampersand is how you actually combine the two booleans there. So you want to say, is number divisible by 3 and is it divisible by 5? You want to combine them with the double and. Same deal here with the or. The English or is actually also not Java. So what you want to do here is replace that with two pipes. So that's the button if you do like a shift backslash. So it's like usually the key between your delete and your backspace and your new line button. You want to do a double pipe there. And the two pipes are what give you your or. So you want to say if it's not 26 or if it's 26 or 32, that's how you do the or. The last one here is not. The not also is not the right Java here. The way you actually get a not in Java, I guess if we think about Python, we have 5 equals 5, and that's the way you compare 5 equals 5. And then you can compare 5 not equal 5, I guess, which we know is false. But the key thing here is that exclamation mark you have in the not equal. That exclamation mark is the same way you're going to get the not. You're actually going to take that exclamation mark and write that here. And that exclamation mark is how you do the not in Java. So what we have as a summary is the double ampersand here is your and, the double pipe is your or, and that exclamation mark is how you get a not in Java. And so now if we compile this, it will now successfully compile. Now we can run this program, which will ask us repeatedly for our favorite number. So if my favorite number was a 3, then it's the multiple of 3. If it was 10, then it's a multiple of 5. If it was 60, then it's a multiple of both. If it's 17, then it's neither. So it is quite terrible. And then 26 is a mystery, as we can see. But now we do have a problem, which was exactly what was pointed out earlier in the chat. This is an infinite loop. If all of my friends have now used this program, how do we get out of it? It's not like there's a nice way to get out right now. So is there a nice way to get out of this infinite loop? We have a while true here, which will literally run this forever, because that's exactly what a while true means. So for now, I can control C, which is like the way of forcing a program to stop. But there would be, if only there was a nicer way to get this program to stop. Or for instance, if you were looping through your robots or something, and you wanted to stop at a specific robot instead of keeping going, is there a way to sort of jump out of the loop or like break out of the loop, sort of break free from the loop? Well, it turns out that break is exactly what you're looking for. Just like in Python, we can say if the number was a 0, for example, you could use 0 as your sentinel value for how to, for like, please stop. So you could say enter your favorite number, or 0 to exit. If your favorite number is 0, then we're sorry. But we're going to say that if you enter a 0, then we're going to break from this loop. And now this how to exit is right here. And so we can say if the number is 0, let's actually output a message here. We're going to say if the number is 0, we're going to say thanks for playing. So if we compile this now, whoop, we compile this now, we can input some numbers. And then if we enter that 0, we do exit the loop there. And so that's how we can have some cool control flow functions in Java. All right, that covers most of the intro to Java. So if there's any questions about it, please continue to post them in the chat. But now what we're going to do is we're going to actually take all the stuff we've just talked about, and we're going to look at it in the context of the example package. So whoops, I just clicked the wrong button. Here we are, we're in example funcs player. So this is exactly where we were before. This is the lecture player that we cloned earlier. So this was the lecture player that we created a bit earlier. I'm outside of Eclipse now because, as mentioned before, I live inside a terminal. But we're going to look at robotplayer.java. So this was the example funcs robotplayer.java. So we're going to look at this together. And we're actually just going to look through some of the main features of what this code is doing. So this code doesn't actually have a main function. It's different to the other code that we've been looking at so far. The reason for this is because the main function is actually written by us. We've actually supplied to you a main function in some of the hidden code that your code gets compiled with, and like it's not actually visible to you right here. So we've actually supplied a main function already. And the main for you is going to be this run function here. So run is actually where your code starts. So what this code is doing is this code says, as soon as I get called with run, now run is, we will only ever call run once. So we will call once per robot. So every time a robot is born on your team, that robot will have run get called. And essentially, once it's called, this run function will control everything your robot ever does. So what we're going to say here is the first thing we're going to say in run is we're going to output hello. We're going to output a bit of a hello world. We also have, so when you say system out print line, this is exactly the print line we were talking about before, we were using before. This is going to output a friendly message to the world that this robot now exists. This here in Battlecode, we also have a function called set indicator string. Indicator strings are another debugging feature. If you do set an indicator string, you can actually click on the robot in the client. And if you look in the top right corner, you get to see the message that this indicator string was set to. I'm not going to share that to everyone here, but if you have questions about that, you can just let us know and we can talk about it on the Discord. But you do have this set indicator string function, which lets you keep messages on the robot for debugging that you can then click around that in the client and take a look at what the robot is saying at that point in time. The key thing here then is that we do have this while true. The while true, the reason we have a while true here is because this robot is going to be making a lot of moves. It's not just going to make a move for one turn and then stop. Like this robot is going to be making a lot of moves. It's going to continue to move for as long as this robot exists, which is why we do have a while true here. So the while true is going to put this robot in an infinite loop, which is going to say just continually find the best move to make. So every time, once you finish making a move, we're going to just come back to the top of this while true and try to find the next move to make. Because the key thing is, if this run function ever exits, if you ever leave this run function, your robot will die because the robot's not running anymore. That's, I guess, the definition of a robot running. If the robot's not running anymore, I guess it's dead. So the key thing here is to make sure that your run function never returns unless you really want your robot to die. So what we have here is this infinite loop that keeps our robot continually running. We have a couple of choices, or we have a couple of things that we're going to do here. Firstly, what we have is we're actually going to keep track of how many turns this robot has been alive. You don't have to keep track of this, but this is just something that we have done for you here in the example player. So we have a static int turn count equals 0. So the turn count is going to represent the number of turns that this robot has been alive. Initially, it is 0 because initially the robot is It's a baby, it's just been born. But for each time we go around this loop, the robot is taking another turn. So each time it takes another turn, we're going to increment that turn count right there. And then again, we're just going to send a message to the world that this robot exists with the turn count and its location. Now, cool. I'm going to come back to what try and catch are. But the key thing here is what Java has a thing called a switch block, which lets you actually choose where to go. And so what we're going to do is we're actually going to switch based on the type of this robot. And depending on this type of this robot, we're going to actually pick one of these functions to call. So for an archon is going to call run archon, miner is going to call run miner, soldier is going to call run soldier, etc. And then for all the other ones, example funcs player doesn't actually create these robot types. So we're just going to say that if we do have a robot that's one of these types, we're just going to immediately do nothing. Just do watch out that for switch, is for some reason it's actually quite important that at the end of every switch case you write break, and break actually breaks you out of the switch. Just keep that in mind. If you leave out the break, you actually continue into the next case, which is why we're able to do something like this. But the key thing here is we're actually going to just try each of these. We're just going to detect the type of the robot, and we're going to call a function that runs that robot. So we have run archon, which runs a single turn for an archon. We have run miner, which runs a single turn for a miner. We have run soldier, which runs a single turn for a soldier. So that's that. We'll go into those functions in a bit more detail in a moment. Other thing to note is wrapping all of this is we have a massive try catch. So this is just like a Python try catch. If something goes wrong, Java will throw an exception. So this is just like raising an exception in Python. So in Python, we talk about raising exceptions. The verb is different in Python. In Java. In Java, we talk about throwing exceptions. And I guess it sort of fits in better with the catch terminology. It's sort of like your function throws something, and then catch is going to catch the thing that was thrown. I don't really know what it means to sort of catch something that was raised. It sounds a bit more funny. So I think Java wins over Python on this one. But we're going to be catching exceptions. Now, the reason we want to catch exceptions is because this is another way that your robot could die. If your robot returns from run, then it stops running. But if you have an uncaught exception getting thrown from run, if run throws an exception, then your robot will explode. So that's also not very good for your robot. So what we're going to do is we're going to make sure that we don't actually throw any exceptions. So the way we're going to do that is we're going to just try to catch them all. So the key exception that you will want to be familiar with in Battlecode is what we call the game action exception. The game action exception is what happens in Battlecode if you ever try to make an illegal move. So examples of this include trying to move into a square that's occupied. It includes trying to mine from an empty square. It includes trying to sense information about a robot that isn't close enough to you. So if that robot's outside your vision range and you try to sense information about it, well, that's illegal because you can't actually see it, and you will get a game action exception. It includes things such as trying to build a robot if you don't have the resources. It includes things such as trying to do any action if your cooldown is too high. So game action exceptions sort of catch anything. If you try to do anything that's illegal, you will get a game action exception. The good thing, though, is that most of the time, game action exceptions should never occur. Because in general, before you do anything, you'll probably check that it's a legal move anyway. So before you build a robot, for example, you'll check if you can build the robot. Or if before you mine lead, you'll check if you can mine lead. Or before you move, you'll check if you can move. But even though you can be very sure that you might never throw an exception, we still strongly recommend you have some catches somewhere, just in case you do. Specific reasons for that include, in Battlecode, every robot gets a specific limited amount of computation power per turn. So it's you can imagine it like a time limit, except it's actually computed. It's like a time limit, except we count it in a way that's guaranteed to be fair and equal every time. And this is called a bytecode limit. And so you get a specific time limit, or a bytecode limit, for every turn. And what actually happens is if you go over that limit, we'll actually just suddenly stop your robot for a bit, and then it will just continue where it left off. will just continue where it left off after on its next turn. So this can be surprising at times. If, for example, after you run this if can build robot, you run out of bytecodes for a turn, and then we hold your robot for a turn. The other robots all get their turn. We come back, it's your turn again, and then you try to build the robot. But since a whole round happened in between because you ran out of bytecodes right after this, build robot might actually now be an illegal move. This should be very rare. But the key point here is that just in case something goes wrong, it's always worth having a good catch just in case. So you never, if something goes wrong, you'd always prefer to be safe than sorry. So we always have a catch here for game matching exceptions, just in case something does go wrong. When we do catch that exception, our way of handling it right now is pretty basic. We're just going to announce to the world something went wrong, and we're going to just move on like nothing happened. If you don't get a game action exception, that means nothing illegal happened, which is always good news. We're just having an extra catch here for just any generic exception. This could be things like the null pointer exception that we saw in the Java demo before. So we just want to be safe. If we try to do anything buggy in our code, we still don't want our entire robot to die. So those are just exception handling. And then finally, what we have is a clock.yield. This is also a very important function call. What clock.yield does is it actually tells Battlecode that this robot has finished its turn. It doesn't want to do anything else this turn, and it's ready to stop and wait for its next turn. The reason this is important is because if you don't have this, this infinite loop is going to go immediately straight back up and start the next turn. Even though to the Battlecode world, like if you're currently doing turn 5, you finish the turn, and if you don't run this, you'll go back up the loop thinking you're starting turn 6. But Battlecode doesn't know you're finished yet. Battlecode still thinks you're running turn 5. And clock.yield is the function that tells Battlecode, turn 5, I am done. I am going to now wait for turn 6. And clock.yield will actually just pause your program. Your program will be held on pause, and it will continue to wait until actually it is its turn on turn 6. And then it will come back and start your program up again. So clock.yield will block your program until it's your turn again. So it's very important to call clock.yield once you're done. Cool. So that's the main part of run. Now we're going to take a quick look at the other functions just to understand what they're doing as well. So run archon is, so we'll notice that the run archon, run miner, and run soldier all happen inside this loop. So these are now only responsible for running one turn at a time. So because we have a while true that will handle the entire lifespan of the robot, now we just have to handle one turn at a time because this is all wrapped inside a while true with a clock.yield. So run archon will run a single turn for that archon. So what that archon will do is it will pick a random direction to build in. How do we pick that random direction? Well, we have an array called directions. So we've created out here. We have a final array directions. And this array directions contains a list of all the 8 possible directions we could try to build in. So this is an array of the 8 possible directions. We also have what we call a random object. So you'll notice that up the top, we imported java.util.random, and we have a random object. And this RNG is going to be our random number generator. So every time you call rng.nextInt, nextInt returns a random integer. And specifically, you can give it an upper bound, and it will return a number. So directions.length is the length of that array. The length is obviously 8 because there's 8 possible directions. And so rng.nextInt8 will return a random number from 0 to 7 inclusive, or you could think of it as 0 inclusive to 8 exclusive. And so we're going to do rng.nextInt, we're going to get a random number from 0 through to 7, and then use that to pick a random direction. Once we've got our random direction, we're going to just try to build a robot in that random direction. So we're just going to say, well, if next boolean is just going to flip a coin, so we're just going to flip a coin. If the coin comes up, say, heads, we're going to try to build a miner. If it comes up tails, we're going to try to build a soldier. And in the direction we picked. So we're going to say, well, if we can build a miner in that direction, then we're going to build that miner. or if we can build a soldier in that direction, then we're going to build a soldier. And that's what run archon does. Cool. So that's run archon, and the other functions are actually pretty similar. I'll come back to run miner because we're going to work on a bit on miners. But the other thing, I'm going to quickly look at soldier. So soldier has a similar bit of code at the end, which is we're going to pick a random direction, and if we can move in that direction, we're going to move in that direction. And if you've been able to run a game by now, you'll probably see your terminal screen get flooded with messages saying I moved, and that's where this is coming from. In addition to that, soldiers are attacking units. So here we have an example of a soldier trying to attack. What this says is we're going to get the action radius squared. So what this says is, well, rc.getType, so you might remember, is we're getting the type of our own robot. So we're detecting what type we are. And then the type of our robot has an action radius squared. So to sort of explain where this is all coming from, let me actually bring up the Java docs. So if you go to the resources page of our Battlecode on our Battlecode dashboard, there is a link to the Java docs, and the Java docs contain lots of useful information about just exactly what is available to you. So specifically, after we were in Robot Controller, and what we did was we just called getType. So what getType does is getType returns the type of this robot. And the type of this robot is going to be a robot type. We're gonna receive a robot type object after we call getType. So this is the definition of getType. It's a robot type getType. And so let's see what robot type actually contains. So there's these different types of robots. So these are the types of robots that exist. But robot type also contains all of this other useful information. And specifically, what we're going to look at is the action radius squared, which defines how far away our soldier is allowed to attack. So we're going to look at action radius squared, which is going to tell us how far away this soldier is allowed to attack. I'm going to come back to our code. So we have run soldier. We're going to detect the action radius squared. Then we're also just going to detect who our opponent is. And so you can also find these functions from the Java docs. So I'm going to detect our own team and then get the opponent of our team. And this is our opponent team. And so then we can actually try to sense all of the robots that are close enough for us to attack. So we're going to find all the robots that are close enough for us to attack and are on the enemy team. And this is our list of enemies. So you'll notice that what we've created here is robot info, which is a class that contains information about the robot. And the two brackets here, remember, mean that we're getting an array. So since nearby robots will return an array of all the nearby robots that satisfy your criteria. So we're going to get an array of all the enemies that we found. So we're going to get a list of all of these enemies. Once we've got a list of these enemies, we just have to check, well, is there more than 0 of them? Because if there is, then there's somebody we can attack. So we're just going to try to pick the first enemy that got returned in this list. We're going to take their location, and then we're going to check if we can attack it, and then go ahead and attack it. And that's the soldier code. So what the soldier code does is it's just going to look around, find any enemy it can attack it, and then move in a random direction. And that's the soldier code. And finally, we have the miner code. So the miner code, we're actually going to work on in a bit of detail today, just a little bit. Our goal for today is actually, we're going to pick apart this miner code, and we're going to make one change to it to make it behave slightly better. So our goal is to sort of make miners behave slightly more intelligently than they do right now. But we're going to notice, first, we're going to just pick apart exactly what it says. So again, we have this same code at the bottom, which says pick a random direction. If we can move in that direction, we're going to move in it, and then announce to the world that we moved in your terminal screen. Other than that, what we have is the main stuff in run miner, which says, I think there was a question in the chat about whether we can check the amount of bytecode we've used this term. The answer is yes. And actually, let me show you this function. So you'll notice that, let's go back up to the top. So clock is the class that lets you to check the state of your code. So you remember that we use clock.yield to end your turn. Clock also contains two other really useful functions. So clock.yield ends your turn. So if you call clock.yield, that's the end of your turn. You can also use clock.getBytecodes left, this tells you how many more bytecodes you have left in this turn before your turn gets forcibly ended. You also have get bytecodes num, which tells you how many bytecodes you have run so far. So both of these functions are available to you in the clock class. So if you can call clock.get bytecodes left, you get the number of bytecodes remaining. So you will say something like int used is clock.get bytecodes left, or no, int remaining, I mean, it is get bytecodes left, or int used is clock dot whatever the function was. It was clock.get bytecode num. And so these two will let you check the number of bytecodes you have used. Yes. So anyways, coming back to the miner. So the last thing the miner does, well, the first thing it does really, but the last thing for us to talk about here is it's going to try to mine on the squares that it can reach. So if we remember that miners are allowed to mine in an adjacent location or on its own square. So this is just sort of like a cheap hack for us to sort of check all the 9 squares around us. So like the change in x is between -1 and 1, the change in y is between -1 and 1. We're going to check all of these squares. We're going to check that location that we want to try to mine on. So we're going to check that a new location, which is my x. So we're going to notice that me is my own location. I'm going to check my x plus the change in x plus my y plus the change in y. And this is the location we want to try to mine on. And then we're just going to say, well, while we can try to mine some gold from that location, we're going to do it. And then while we can try to mine some lead from that location, we're going to do that as well. And this is what the miner says. Cool. So the next thing we're going to do is we're actually going to start editing this code. But before I do, Andy, do you want to tell me if there's any other questions in the chat that I haven't answered?
Right now, I think somebody just stated just now that the video is not moving, though the sound is coming through. I'm not sure if this
is not moving, but the sound.
I think this. It seems to be working for me though, so I suspect it might have to do with their end. Besides that, I don't think anything else has been answered.
Well, hopefully your connectivity gets resolved. If not, this video, like this stream, we will publish to YouTube. So you can definitely go back and rewind to see what you might have missed. We'll also additionally be available afterwards for office hours if you want to clarify anything else. But cool, what we're going to do then is we're going to move on to trying to make some edits to this code. The first thing I want to do actually though, is I want to point out that as you make edits to example funcs player, you might start feeling that your code is getting really long. Like this is already like almost 200 lines, which is a lot of code. And perhaps you don't want to be dealing with that much code in a single file. So what we're going to do is we're actually going to start breaking this up into some smaller files so that it's actually easier for us to be able to sort of move in and between files. So what I'm going to do is I'm going to create a new file. I'm going to call this file minerstrategy.java. So this is a new file called minerstrategy.java. And minerstrategy.java is going to contain all of our strategy for miners. So what we're going to do, we're going to say, well, minerstrategy.java is also in package example funcs player. We're also going to import battlecode.com, and we're going to do all of this stuff. I'm going to have a, so the only class that needs to be public, you don't have to actually worry too much about why it needs to be public, but you just need to know that the only class that absolutely has to be public is Robotplayer, and the others don't strictly need to be public. You can make them public if you want. So we're going to create a class called minerstrategy. Okay, so with minerstrategy, I'm actually going to just copy some of this code here. So I'm just going to copy the RNG. Actually, let's not copy the RNG. Let's actually talk about how to use the RNG in here from minerstrategy. But what I'm going to do is I'm going to take all this miner code, so run miner, move it from Robotplayer. I'm going to paste it here in minerstrategy. So all of that code about the miner is now here in minerstrategy. Cool. So I'm just going to check that I'm on Java 8. Awesome. And first thing we're going to do is I'm going to actually compile this and show that it doesn't actually compile at all. So so we actually have to do a bit more work than just moving code around. So if we try to compile this now, we have a couple of compile errors. Specifically, it can no longer find things such as run minor, and inside minor strategy, it can't find things such as directions or like our RNG anymore. The reason for that is because run minor, as we call it here, belongs not inside Robotplayer, but it's been moved to minor strategy. And then the directions that we're calling here and the RNG don't belong to minor strategy. They belong to Robotplayer. And so we actually have to tell them where to find them, because by default, they will act, if you say run minor, it will just look for run minor inside your Robotplayer, and it will just look for directions and RNG inside your minor strategy. They don't actually go across to each other. So the way you fix that is you take your run minor. I'm going to say that this is actually inside minor strategy. This is inside minor strategy. And you don't need to import it. The reason you don't need to import it is because they're in the same package. So if they're in different packages, you would need to import it. Because they're in the same package, you can just get away with directly saying minor strategy.run minor. Just to note that in Battlecode 2022 this year, you're only allowed to submit one package. So do try your best to keep all of your code in one package. You're allowed to scroll into as many files as you would like to. So we're going to do minor. We're going to do minor strategy.run minor, which will then bring us into here. At the same time, we also have directions and the RNG, which are in Robotplayer. So we can do robotplayer.directions. And we can do robotplayer.rng. This code is getting a little bit long here. I'm going to say int direction index is the stuff. And then we're just going to do direction index here. So this is what we've essentially done is we're going to say we're going to use the RNG in Robotplayer. And we're going to use the directions in Robotplayer to get our random direction to move in. So we compile this now. This should hopefully compile. And there we go. It successfully compiled. Cool. So this code actually does the exact same behavior as example funcs player. All we've done is we've now actually split it into multiple files. You'll notice that Robotplayer is now no longer 200 lines, it's just 150. And so you can do this to sort of split your code apart into separate bits and pieces to make it easier to manage. So otherwise, if you have a really long file, then like sort of control Fing through it to find one piece of code can be pretty hard. But if you split it across multiple files, then it's sort of easier for you to sort of get a feel for just what you're sort of looking at and trying, and sort of being able to move between files a lot easier. Cool. So the last thing on the menu for today is we're going to improve our minors to do one thing more cleverly. So the code for Battlecode 2022, and I guess the code for any Battlecode, can be really intense. There's like definitely a lot happening inside the code. And the key thing is that most of the time, you don't actually need to use all the features that are available. The way I think of making a Battlecode bot is a lot of it is about making it's like a month of making these incremental improvements. You think of it as every time you look at your code, you're going to find one thing that it's doing that you think that doesn't really make sense. Like, why would I want my robot to do that? And you just take this one thing and you change it to something better. And then every time you make that change, your robot does something slightly more intelligent and you have a better robot. And so if you continually do this, every time you're just going to pick one thing that it's doing that seems sort of silly and you make it better. And if you just make it better lots of times, then something that is many times better than example funcs player will actually be a really good bot. And so this is actually what I think is one of the best ways to approach something like Battlecode, which is actually like, overall, it's a very large piece of code. We are dealing with 200 lines already. But rather than trying to sort of take it all in one go, we're actually going to just look at it piece by piece. And then every time we're just going to make that one change to make it better. And then eventually the series of changes will bring us to something that's a massive improvement over example funcs player. This change we're going to make right now, we're going to look inside here at run minor. I'm going to just talk about why run minor should be moving randomly. This seems like a very strange thing for us to do with minors. Like, if we have a minor and it sees around it that there is a resource square, it sort of doesn't make sense for it to just move randomly. Like the job of the miner robot is to mine resources. So the change we're going to make today is we're going to say that instead of always moving randomly, we're going to say that if the miner can see that there is a resource square nearby, it's going to try to move towards that resource square. And that's what we're going to be doing today. So to do that, we're actually going to have to try to detect what's around on the squares around us. So there is a very convenient function. So we're going to go back to our Java docs. So inside this, we're not going to be looking at clock anymore. We're going to be looking back inside Robot Controller. So Robot Controller tells us all the ways that we can interact with the Battlecode world. So there is a very useful function, which I just have to find here, which actually gets all the locations within a certain radius of a center. So in other words, all the squares within a circle. This is really useful for us because we can use this to get the set of all the squares that we can sense. So what do I mean by that? So let's take a look at this. Let's say that, let's just make this slightly bigger. Let's say, so we already have me as my location. We can also say that my radius, so my vision radius, which is the radius that I can see around myself. So my vision radius is going to be, my vision radius is equal to, if I detect my type, so rc.getType is my type, and I have vision radius squared. This is going to be the radius squared that my miner can see around myself. Using this, I can then use that function that we just looked at in the Java docs and say map location, nearby locations. Let me just, yep. So nearby locations is going to be rc dot, I'm just going to call that function get all locations within radius square, and it's going to be the first argument to that is the center, which is my location, and then the second parameter is this radius that we're taking, which is vision radius. We're going to use that, and we're going to say we're going to detect all of these locations around us. Cool. Once we've got the set of nearby locations, we can actually try to find one that contains resources. So what we're going to say is we're going to try for each location in these locations. So map location, try location, inside these nearby locations. We're going to see, so what we're going to say is for each nearby location, is there any resource there? So is there any resource in that location? So what we can say is, well, if rc.senseLed in that location is greater than 0, so if rc.senseLed is greater than 0, then there is lead at that location. Or if rc.gold in that location is greater than 0, then yes, there is resource here. So if there is resource here, then we should consider going here. So the way we're going to consider going here is we're going to say map location, target location. We're going to pick a target location. And then if we should go here, then the target location is this location that we just tried, because we know that this is a good place to go to. This is going to be our target location. And if we don't find one, we're going to say that this target location is going to be null. So it's going to be the Python none. Once we found a target location, we can also break out of this loop, because what we're going to say is if the target location is not null, then we have a target location. Let's move towards it. So we're going to move towards this target location. So the way we're going to do that is we're going to find direction to move. The direction that we're going to move in is my location dot direction to. So there is a very useful function that you can run on map locations, which takes my location dot direction to target location. Be very careful that you don't write map location dot direction to target location. This doesn't actually work. Don't do this. You want to be taking my location's direction to target location. because specifically the way this works is you want to be taking the direction from one direction to another direction. So map location doesn't actually know where you are. You have to tell it where you are and where you want to go. So you're going to take my location. So me is rc.getLocation. I'm going to take my location and the direction to the target location. And we're going to say if rc.can move in that direction, then we're going to move in that direction. So this is just one small change. But what we've now done is we've said to the robot, if you can see a location with resources around you, you should go towards that location. Now, this is one small change. There's actually some other questions that you could be already asking, which are questions such as, well, if there are multiple locations among these nearby locations that contain resources, which one should we go to? Should we just pick any of them? Perhaps you might think, well, we want to be picking out of all of these, we want to pick the one that's the closest to me instead of just picking any single one of them or the first one that shows up in this array. Maybe we should be picking the closest one to me to go towards, because then I can get resources faster. And if you wanted to do that, then this is something you could do as well. So you could do something like int distance to target is 0. Distance to target, let's start it off at infinity, because we're going to say is if the target location, if my location is this distance, let's actually say that int distance to is my location's distance squared to that location. We're going to say, well, we're only going to replace it if my distance to is better than the distance to the target. And what this does is we're going to say, well, if this distance is better than the distance to the target, then we're going to say that we have found a better target location. And something like this will now make our robot go towards the closest target location, the closest square with resources that it can see. And so on. You could possibly even make other improvements, such as preferring gold over lead or something like that. But this is sort of like the initial steps to making a robot do something more clever, where essentially what we've done is we've just taken one thing, which says, well, why always move randomly? When if we know that there's a clever move, why don't we just try to do that instead? And only when that fails do we actually move randomly. So this is sort of like the idea of like how we can actually get started with a bot. So every step on our bot, what we're doing is we're just taking one thing that looks a bit silly, like why would you move randomly all the time? And then replace it with something slightly cleverer, which is instead of moving randomly, let's actually try to go in the direction that we know is good. And now let's actually run this. Let's actually just compile it first. I want to make sure that all the code I write compiles. It's very important to have code that syntactically works. All right, that's looking good to me. And so the code compiles. We could try to run a game. Could take a while though. Run. Let's run it on the. Let's run it on Eckelberg. Oh, Eckelberg's a bit big. What's the other map? Intersection. Let's run it on intersection and see what happens. So if we run this on intersection, then we're going to be running this match. And oh dear, we have some exceptions. We have a null pointer exception. This is no good. You should not write code that throws null pointer exceptions. Okay, so moral of the story, make sure that your code works. We have distance squared to target location. Okay, we should not have used target location here. This is also another moral of the story is you should always, you should never write code live. When you write code live, it almost never works. But notice here that we're checking the distance to the target location, when in reality, we should have been checking if the try location is better than the target location. Here, what we should have done instead is we should have taken the try location there. So hopefully this no longer throws the nulls, because notice that at the start, target location will always be null. So we're always checking the distance to nowhere. So having conquered that slight mishap, we're going to have another shot at seeing if our code runs correctly. And it does seem to run successfully. So if this code finishes in a decent amount of time, I'm also going to play it in our client and see it going towards the resources in a very fast way, instead of sort of idling randomly around and eventually getting there. But while we wait for this to run, are there any questions in the chat or anything else that we could clarify?
I think some people are having some issues with the scaffold, but I think that's being resolved.
Okay, we can also keep the scaffold discussion in Discord afterwards if people want, so that we can keep the Twitch chat concentrated on content related to this lecture.
Yeah, I believe there aren't any other questions.
Okay, there's also a comment that I should have updated distance to target. My code is littered with bugs today. I should not. Cool. Cool. There was another question about how to see enemy players. This is a good question. If you wanted to see enemy players, you can actually say rc.sense robot at location at describe location. And then you can check if r.team is equal to your team's opponent. And then that's an enemy robot. Or you could sense all the nearby robots on the enemy team using something like this, which gets you the list of all the enemies. This gets you all the enemies around you. Okay, but I am going to rerun this game because I should indeed have updated distance to target. So after we find the distance to, we should have updated distance to target. So I'm going to rerun this game here. But while we rerun it, I am going to start up our client. All right, so the client is firing up. I'm going to wait for this game to finish running. All right, so we're on round 1,000, so we're halfway there to the 2,000 round limit. And once we have that, we should hopefully see that our miners are intelligently moving towards the closest square with resources. So they'll be a lot faster at mining the map. With 500 more rounds, we're almost there. Can a bot do something to store a variable between turns? Yes, it certainly can. In fact, our example func player is already doing that. If you look at our int turn count here, this turn count is stored between turns. So turn count doesn't reset to 0 every turn. The turn count tracks the age of the robot. And so so if you want to store something between turns, we recommend keeping it outside here or something inside, like not inside a function. So we keep it outside. Then with a turn count, over time, every time the turn runs, it will increase. So turn count will increase, and so you will actually see that the age of the robots are increasing. So we have some 170 turn old robots. So yes, you can certainly keep track of variables between turns. So as long as you keep them outside, then the next time your code runs, it will just pick up from exactly where it left off before. Cool. So that just finished running. So let's share up our client. So this is the client. Is this the game we just ran? I'm not actually sure. I'll just re-upload it. Matches. What did I just run? I just ran it on intersection. So let's upload this intersection game. And let's give it a play. Let's see the miners working. So you can see the miners went directly to that. They went directly and went straight and took all of the resources they could see. So they mined that map dry very quickly. So these miners are a lot more intelligent than the ones in the pure example funds player. But that covers the main content that we have for you this lecture. So from here, this is essentially the official end of this lecture. We're going to move into office hours. So we're going to be hosting office hours. We're going to have them on Discord. So let's just use the lecture channel on Discord. So if you have anything else that you would like help with, anything to do with installation and setup, anything to do with Java, anything to do with the set of changes that we just made to example funds player, please do ask away in the Discord channel and we'll be glad to help you. So we're going to be moving into office hours and we're going to be looking forward to meeting you on Discord. But other than that, this is the official end of lecture 2. So good luck to everyone on your bots. And other than that, we're looking forward to seeing you in Discord and tomorrow for lecture 3. So that's the end of the lecture and looking forward to seeing you all around.